Thanks. Okay, quick show of hands. Does anyone here know what GraphQL is? Cool, okay, great. Has anyone ever used it, deployed it in production? Okay, a lot less, great. Okay, so this talk is going to focus more on GraphQL than on the serverless elements of it, because actually that's where most of the complexity is around implementing GraphQL. The serverless stuff is kind of easy by now, well, in theory. So a quick introduction who I am. My name is Stanley. I run the Serverless meetup in London. I'm one of the co-organizers of Serverless Days, which is a community-focused series of serverless events around the world. Previous life, I was a co-founder of a business called A-Cloud Guru. And with A-Cloud Guru, I ran the first Serverless Conf in New York in 2016. Shortly after that, I left A-Cloud Guru and took some time off. And today, I'm a contractor. Pay me money, I'll come deploy serverless architecture for you. Any other buzzword you want? I'm really going to focus on GraphQL and serverless. Being with A-Cloud Guru, we had a very early, we were very early adopters of Lambda and the whole serverless way of doing things. And implementing, beginning of this year, did a multi-month project where we implemented GraphQL within Azure Functions. And the learning curve, and the problems always had with it, wasn't actually learning Azure Functions, which has its own learning curve, but it was more like learning GraphQL, how it works properly, and what it really is. Because what you find is most of the tutorials you find online, most of the videos you find online really focus on the front end. There's not much on the back end. All the examples are really, really trivial. So I want to try and give more of a deep dive into GraphQL, and if you have a better understanding how that works, it's easier for you to implement it on a functions as a service platform. So what is GraphQL? It's an open source framework created by Facebook, created in 2012. They open sourced it in 2015. One of the internal business units created it. I think it was Photos, or might have been something like that, created it. And they were running it internally for 3 years. All of Facebook runs on GraphQL today, from what I understand. But they started using it in 2012. Literally, it means graph query language. This is the biggest misnomer. Since you had a serverless talk, things that are badly named, this is a good place to be. So it's not a graph database, and it's sort of a query language, but not really. Parts of it aren't. Parts of it is. There was someone well known in the database community went on a bit of a Twitter rant 2 days ago comparing GraphQL to SQL, and it's two completely different things in many respects. So, at its core, it's a specification. You can go and read the specification there. It's plain old HTML doc. It's incredibly boring. It will put you to sleep if you try and read it. This is a diagram or a variation of a diagram you'll always see. What GraphQL allows you to do is take multiple backends, aggregate them, and present one endpoint to your client. So your client can make a call against a GraphQL endpoint, and that endpoint can then query backend services. And then on top of that, whether those are databases or another API or whatever it is. So that's kind of the basic diagram that you'll always see. And if you see any kind of GraphQL tutorial or blog post, you'll always see something like this. Essentially, it's this little piece in the middle that does this gateway function. Front-end developers love it, because the reason being is that, and it's great for front-end devs, is imagine you're writing Facebook as you do in your spare time, but you've got these multiple services in the back end. If you have to call the like button or the photos or the news feed, an individual REST calls every time, that's multiple calls you're making to the back end of GraphQL that aggregates into the one call. And then you can overlay functionality on top of that once you've done that. So it simplifies the front-end developer's life significantly. At its core, it's a type system. It does have a query language in it, and it's implemented via a gateway server. You'll hear a GraphQL server. It's not really a server, but that's the thing which implements the lightweight query language in the type system, essentially. So what does a type system look like? A type system is types. So you declare your types like this. So you can create a type, custom type called author, associate ID, name, bio, whatever. Say you've got Gravatar URL. This is a blog post example. You might have a comments within there, ID within that. You have kind of standard types, scalars that come with GraphQL, string, ID. You can reference another type within a type. So you've created this type author, you reference it down there. You've created a type comment, you reference it down here. By putting in brackets, you say it's a list, so that will be an array of comments. It's a type system. It's a really easy way. It's a simple language to define types. The most important bit to understand here is these are types. These aren't databases. These are just data types. It's a way to enforce some sort of standardized data and normalization on your data sets. You can extend your types. So you have your default scalars. You can extend and put custom scalars. So for example, date time. So if you want it in ISO format, you can add a scalar to that. And then, cool, let's add this field last edit to our article type, date time. So there's ways to extend it. So like JSON is another very typical scalar you would extend the type system with. So it's extensible as well. That's the other bit. And you can enumerators. So if you want, for example, create a set of tags, it's an easy way to create it. So it's kind of standardized data that doesn't change. So rather than fetching a standard list every time, you can just, within the GraphQL server, define your enum. So that's the one part of it. The most important bit to understand is that the type system has no explicit definition of an underlying data structure. I think sometimes people think it is. It actually isn't. You can, if I go back here, I can have one nested data structure that holds that. I can have a document database that holds all of that, or I could have a more relational database that has a table for that, a table for that, and a table for that. GraphQL does not explicitly infer a data structure. It implies it, but it doesn't explicitly create a data structure underneath. So that's kind of types in a few minutes. The lightweight query language component, like the reason I said it's lightweight, GraphQL, is it a query language? It is, sort of. Comparing SQL and GraphQL is apples to oranges. They are very different things. I'll give you a very high-level reason why. So SQL, you have a concept of data definition language. So create alter statements, you create tables, alter tables, create databases. Example, you know, there's the XKCD comic, or Bobby Tables here. The drop table is a DDL statement. So GraphQL does not have DDL statements. There's no way, because there's no explicit definition of underlying data structures in GraphQL. SQL has data manipulation language. So this is where GraphQL and SQL become a little bit more similar. Select, insert, and update kind of statements. So GraphQL language internally is referred to the schema definition language. So that's the language that is used to define the types. And it's the language you use to define your operations. So schema definition language consists of types and operations, and the operations can be query, mutation, or subscription. In reality, everything's a type. In GraphQL, everything's a type. A query is a type, a mutation is a type, a subscription is a type. You have special types, essentially. But these are the three operation types. So you have the schema definition language, which you use to define your types, your operations. So let's say this is a query, and you can have multiple queries. Let's say the same example, article, author, comments. Let's say get article. There'll be a query, define a variable you want to pass to it, and it will return an article. So get author. So these are the things I've created. Return ID. I didn't actually create this, but you could, let's say, have another type called a blog, which is an aggregation of those three. Return the slug for it, and return a blog post, for example. Or you want to list them, or return a series of, a list of blog posts. Mutation. Now, this is if you want to update, delete, do kind of CRUD operations on your, whatever your underlying data is. So the same example again. You can create an article, and these will be the required or non-required string. If it's got an exclamation mark, it means it's required. If it doesn't have an exclamation mark, you can leave it out. You can return null. Once the mutation's done, it will return article, or whatever it is you want it to. And that's your data type. So you just keep referring to types the whole time. That's quite lengthy to write. There's a way to improve that. Then you also have subscriptions. Let's say you want to watch a comment and you want to watch it by article ID, and that will return the list of comments. Subscriptions in GraphQL, the implementation is very language specific and very specific to the library that's using it. So I'm going to kind of gloss over it because I'll come back to it later because there's a lot more detail that's very specific to the language. But a subscription is essentially a persistent query that as the underlying data changes, it'll fire and it'll run that subscription again. And same again, it's a type. Everything's a type. So earlier, if we go back to, this is really long. You can bring that down and can create what they call input types. So you create input types, so that's a predefined type. And you say, okay, now I have an input type of article input. So every time you use it, you can just reuse that input type multiple times. It's a more efficient way to write the language rather than writing everything out. You also have concepts of things called interfaces, which are similar to input types, and they can also be used for validation as well. So I could potentially change that to an interface rather than input type. So some really quick examples of a query, like how it would actually work from a client-side perspective, and you define it. So you define your query in your schema, your larger schema. This is actually what a query would look like. You can create an alias for your query. So that's just something that your client application would find friendly to recognize. You map a variable ID to an ID field, and then you does this reverse mapping back. And that's a query I defined earlier. So this get article query. Now we'll return the type article, but you don't actually have to return everything. You don't have to return that entire type you've defined. You can just return specific fields. So in this instance, I just want, out of article, I want the ID field, the title field, and the abstract field. So you don't need to return the entire type every time, which is really useful when you have multiple clients using the same query. You know, you might have the same get article. You might just want to get an excerpt to, let's say, populates a contents table. In other instances, you might actually want to get the entire thing. So you can use the same query for the same thing, just bringing back different data. And then what it actually looks like in a post statement. So if you're using HTTP as your transport mechanism, HTTP post, you'll have a query field which actually has that query that we've written earlier. So that's literally that query written passed as a string, and then you apply your variables as a second string. So the GraphQL client will get this ID, map it back to there, map it to there, and it'll execute your query. So it's query. And you'll get your data returned like this. So data, current article, and then whatever you've asked for, the ID, title, abstract. It's relatively a simple way of working. It's front-end developers really like it, and it gives you a consistent way to work across all your data types. Another example around a mutation. So let's say we've got the input article, article input type. Same again. There we go. Okay. Mutation, you have an article variable as an object. Same again, and you'll return your ID, slug, status, last edit, so create article, for example. Your query will still ask for article variable. That maps to this. You have your object. If that doesn't have the correct detail in it, you'll get an error. So title, abstract, status, that's what the input article referenced. And you'll get your data back like that. It's relatively simple. And once you start writing GraphQL queries from a front-end perspective, it becomes really easy. You can go through this really quickly, and you don't have to understand how a REST API works and what the differences are between multiple APIs you might want to be called. You just need to understand the data structures, the data you want, and the data you're going to expect back. It's not that. So it's really easy for front-end devs. The same again is that the query language, the operations, there's no explicit definition of the underlying data structure, and that's kind of an important bit with GraphQL. So let's get to the last component, this gateway server. It's actual implementation detail that applies all of this. So GraphQL server, the reason I always put server in brackets, because it's stateless middleware. All it does is interpret GraphQL schema and interprets queries against it and responds with data. It doesn't do a whole bunch of other things. So it's no transport. You can implement GraphQL on with any transport mechanism you want. HTTP, WebSockets, gRPC if you want to, MQTT. You can implement it in any transport mechanism. There's no authentication built into it. There's no observability or monitoring built into it. You don't know what's happening to this thing. You can build this stuff in. That's the thing. It's extensible. But the fact that it's stateless middleware makes it a really good candidate to run in a functions as a service platform, which you should be writing stateless functions. These are the multiple implementations you're getting at the moment. So 10 different languages. There are often multiple languages, implementations in each language as well, I think. And then on top of that, you get libraries on top of, you get frameworks that then extend the server as well. So pretty much name a language you want, and it's most likely supported. Like Medium use GraphQL, and they use the Scala implementation of it. I think Honeycomb, are using the Golang implementation. I'll double check. But yeah, so it comes in multiple different languages. Most popular is JavaScript for multiple reasons. JavaScript was the first implementation written. It's the reference implementation. So the recommendation is if you're going to write your own GraphQL server, go look at how the JavaScript GraphQL server is written, because that's written by Facebook. And that's a reference implementation. There's also a C implementation that Facebook now use, but that's not there. But anyway. This is from the GraphQL kind of concepts from their GraphQL site itself, to give you an idea of how the server is implemented. The authorization layer, they say, should be outside of your server. Your business logic layer should be outside of your server, and then persistence layer. It should just be a tiny endpoint that sits on top of everything. It can run alongside REST. It can run alongside any kind of RPC type servers you might be running. It doesn't necessarily have to replace. It can run alongside. And most GraphQL implementations you see are not big bang where companies are migrating. They are implementing one individual component and GraphQL, and they slowly move everything else under GraphQL. So Medium's a good example of this, where you go to the Medium homepage, nothing's GraphQL. You go to the Medium, you look at, view a blog in Medium, blog post in Medium, and that's a GraphQL query. So slowly, kind of it's a really typical implementation pattern. It's going to still have that here and then slowly move stuff across there. And the recommendation had the authorization outside of it. So GraphQL JS, reference implementation version 14.0.2 is the latest. One of the interesting things about 14.0.2 is it implements ES modules. So they ship two versions of it with version 14. They ship an ES5 version, and they ship ES7 version, essentially, so with ECMAScript modules, which is important for FAS. I'll explain later. There are lots of people who have shipped their own versions of the GraphQL JS framework, and the reason for Apollo and Prisma have set up their own version. They've got frameworks that wrap around GraphQL JS, and then AWS had the AppSync service, which is GraphQL as a service. And they add things like an HTTP server, WebSockets, authorization, caching, pagination, some code gen, some logging and tracing they add to various degrees. For example, Prisma doesn't really, or they do have a package which adds it, but their core library is really focusing on code gen and some of this stuff. Apollo tries to do all of it, AppSync tries to do all of it. And there are benefits around this. It's very rare, if you're using JavaScript, that you'd run the native GraphQL library on its own. You normally run one of these frameworks with it. Or Apollo or Prisma, typically with it, sometimes both. As an aside, the GraphQL Foundation is being formed at the moment because there's so many people getting into GraphQL, and there's no one actually, Facebook's not really curating it. They don't want to be an open source software foundation. They've open sourced the software, but they're not really doing a great job of being a steward of it. So they're creating a foundation to kind of give greater definition to what really GraphQL is, and there's been multiple problems with it before. But particularly Prisma and Apollo both like to have their own definition of what GraphQL is. And they're, yeah. Anyway, so if we go back to that previous example, with implementing GraphQL, what you can do is you have your schema. You could potentially have all your author details, your author type sitting in a third-party service, let's say WordPress and a Gravatar service, for example. Comments in one database, let's say that's a NoSQL database, and your articles in a relational database, for example, or vice versa. And it's one endpoint your client calls to do that. But the question is, how does it get these things? So within GraphQL, you write things called resolvers. So basically, a resolver is a thing that fetches your data from the backend. When you call a query, let's say create post, that will call a function. So that function is literally whatever, it's literally a code, function written in code as your GraphQL server. And that will retrieve your data. And you get two types of resolvers. You get a default resolver. So if you've got an operation like a query operation or a mutation operation, you can have one resolver per query, one resolver, or mutation subscription. So that's a one-to-one relationship between the name of that resolver, the name of that query, and that resolver. So if you've got the query get article, you'll create a function literally called get article, and GraphQL will map those two together. So it knows someone invokes, does a request on this get article query, it knows it needs to invoke this resolver to go and get that article. That's what a default resolver. A field resolver, a little bit more complicated to write, on an individual field. So I spoke about that type system earlier, where you can have multiple fields. You can have individual fields have their own resolvers. So you can have a type with 10 types in it, with 10 fields in it. Each of those 10 fields can have their own resolver if you really want to. That's starting to get a bit more advanced. There are implementation differences between default resolvers and field resolvers. Field resolvers are significantly harder to write, or implement, should I say, because GraphQL ships with a whole bunch of utilities, which can just translate your schema into executable code. You can't use those utilities to translate your default schema, your schema into executable code if you're going to be using field resolvers. Most examples won't be using field resolvers. You'll see a few, but most examples won't. So most of the time it's the default resolver. There's also, it's useful to know when you're using default or field resolver, but 99% of the time you'll be using a default resolver. So what does a resolver look like? So use a get article. So this is just a function called get article. It's got the standard parameters, a root object, which is kind of the context is called in, arguments, and then context. Context is anything you really want to pass through. So it could be like a user ID if you want to implement authentication in here. It could be other things as well, like a language or location or things like that. Let's say whatever random database SDK we're using, let's set a NoSQL query, create a query, pass it there. Whatever's returned will return. So you just basically mapping your fields to whatever your filter value is going to be, and off you go. It's not particularly hard. It could be anything, as long as it's just a function that fetches data. Where it fetches that data from, GraphQL doesn't care. What it does with that data, it really doesn't care. You could rewrite that. If, let's say, you're back into SQL backend, you could rewrite it as a SQL statement. Prisma has built ORMs. They call themselves the GraphQL ORM for Mongo, Postgres, and MySQL. It's an ORM, so it's going to have all the problems with an ORM, but it does make some of your life writing resolvers a bit easier. Don't write resolvers like this, because you want to do things, you probably want to add some tracing in here, some logging in here, what happens if it fails, error handling. This is just a simple example. So I'm doing exactly what I've complained about. Is every example you see is far too simplistic. You want to be doing validation of your inputs and things like that as well. But it's basically resolvers are somewhere where you can write your own code to validate and fetch that data. How GraphQL, this is actually going back to the schema, even though I'm using JavaScript here. If you've got your schema written in that schema definition language, so all the types, queries, mutations, all of that defined, within GraphQL JS, it's got an internal function called build schema. So what that does is, I should go into this here. So what that does is it takes your schema definition language, it runs a function called parse that outputs abstract syntax tree of your schema. So that interprets that schema, and then it calls another internal function. It's actually called build ATS schema, which then outputs a GraphQL schema object. GraphQL schema object is a proper It's a JavaScript object, which has its own challenges. So within that, there are functions. Within that, there are lists. It's quite a huge kind of blob. And this takes a bit of time when it does. So typically when you are invoking, you want to do a GraphQL query, first thing you do is you build your schema. Second thing you do is then you invoke the GraphQL server. So once you invoke the GraphQL server, you'll take your schema. So this is your schema object. Then you query whatever's been passed it. And then your root object, which is actually your resolvers, if you're using default resolvers. So you pass all your resolvers in there. So then it does the second thing. So it passes the query to make sure it's valid. And then validates the query and the schema against each other. And then it executes. Yeah. And these steps are actually in the GraphQL spec. So these aren't just, I'm just going through the JavaScript implementation, but every GraphQL server will do the same steps. Pass, validate, execute. Every time you invoke the GraphQL method from the GraphQL server, it will do that pass, validate, execute every time, which is important for performance considerations. And the other thing, schemas, your resolvers have no explicit definition of the underlying data structure. Like you can do a mutation and it can write to a pub sub queue. It doesn't have to write to a database. It could write to an S3 bucket. It doesn't have to write to a database. There's no explicit definition. You just define the types for what your clients are going to see. How you want to define that underneath can be something completely different. Because as you see, the code to fetch that data, you write yourself. Or you use a tool to generate the code. Okay, so let's actually get to the serverless components of this. This is a great thing. GraphQL server equals stateless middleware, which is awesome for fast. Every time you write something that functions as a service, you want your functions to be stateless because they're going to be short-lived. So this is a really good, simple example from Serverless Inc. They've got a plugin to get GraphQL running within Lambda. Implements API gateway, exposes an endpoint. Endpoint maps to a Lambda function, runs your GraphQL server, which then you can write your resolvers to call whatever you want. That works well. Bustle, who are a US company, I want to say they're like a BuzzFeed. They're sort of, their niche is a bit different. They've actually got 3 or 4 different titles. Bustle's the biggest. But across their multiple titles, they've got 90 million monthly users. Their average invocation time is about 70 milliseconds. And all their front end talk to a single GraphQL endpoint. That GraphQL works incredibly well for them. They do pre-render a lot of their pages, but when anything's live, it talks to the GraphQL endpoint. Thomas Cook locally in the UK in 2015, what's 2016, 2015, they had a unique problem around, or not unique, around search. So Thomas Cook, tour operator, they had this issue where most people who would search for holidays wouldn't buy. Like the ratio of people completing the checkout to starting the search there's a huge disparity. Because when you're looking to book a holiday, you'd look multiple options, you do multiple searches. So what they found is they had this monolith which tightly coupled the search and the whole checkout. So they're having to scale the entire checkout for a whole bunch of searches that were never resulting in sales. So they decided to decompose just the front end with a single function using GraphQL. And that allowed that rapid scaling on their search API without having to scale everything else. So that's all they did, and they did that in 2015. Bustle have been using GraphQL, I think, since about 2015, 2016, that kind of timeline. Those are 2 of the bigger examples I know of in a serverless implementation. I've implemented it in Azure Functions and Google Cloud Functions. The patterns are the same across all of them and how you implement it. Where the difference is how you write those resolvers and the underlying data stores you use, whether you're using Cosmos DB on Azure, BigQuery on Google, DynamoDB on Amazon. That's kind of where the complexity gets, and that's where you see the differences is writing the resolvers. But all the defining the types, it doesn't matter, which gives you nice portability to a certain extent. Beyond then, there are GraphQL as a service. AppSync is GraphQL as a service from Amazon. They will auto-generate resolvers to go to Elasticsearch, DynamoDB, Lambda, and Lambda you can use to call a REST API. They will create resolvers that do that. There is a problem with AppSync in that the two issues is that it exposes a lot of the underlying data structures up to the GraphQL resolver. So one of the resolvers they will always auto-create is a list resolver. So list all items in a DynamoDB table. You want to filter on that. So for example, you want to see all items that equal Jan, for example, where the author name equals Jan. You then have to write a DynamoDB input filter to do that. So you need to have knowledge of DynamoDB. So that's one of the issues I have with AppSync is that it's exposing implementation detail of the database all the way to the front-end developer. I don't know many front-end developers who want to learn about DynamoDB input filters. The other problem you're going to have with it is if, let's say, you are developing locally and you've got a little GraphQL server running locally and you create your schema, you upload it and you just copy, literally you can take that schema definition language doc and copy and paste it into AppSync. And then you can choose which of those type fields you want to actually make as databases. You can do that and auto-generate those resolvers for you. Any queries you've written, the types will be there. It's not going to generate resolvers for them. You then have to create Lambda functions for each one and then copy your code across. So portability is not that great with AppSync either. So those are kind of two of the issues I have with AppSync around portability and how it exposes the implementation details of the backend to the front-end dev, which as an abstraction, you don't really want it to do that. Another service called GraphQL. So the people who wrote Prisma, they started off with a product called GraphQL, which is essentially GraphQL as a service. They had the GraphQL API gateway, and then had a bunch of subscription API, event gateway to invoke a FAS, and then a CRUD API. I think that FAS was web tasks. Web tasks. And CRUD API over MySQL database. I had a good friend who wrote an app that had about 6 million users on it using GraphQL. They fell over. I think the big reason they are moving away from doing GraphQL as a service and rebranded themselves to Prisma is these guys are great developers. Operations is another task. So like my mate had issues getting database backups from them. And the only interface you had was a GraphQL interface, which you can't manage a database with. So if you want to delete data, unless they present a query, you can't do that. Because these guys auto-generate your queries and mutations for you. So that's another issue. You've got to be a little bit careful sometimes with some of these GraphQL as a service providers, because like how do you manipulate, how do you manage that data, how do you get it back up yourself? And these guys kind of, front-end dev experience great, but when it came to the operational stuff, they kind of fell down a bit. So now they're moving to more of a software product. So some caveats. GraphQL, a stateless middleware. The transport isn't always stateless. If you want to implement GraphQL in FAS, no subscriptions, which is one of the biggest problems because subscriptions tend to be, most subscription mechanisms, so if you WebSockets, for example, tend to be, where you have bidirectional communication, tend to be stateful. The server needs to understand who its clients are. A stateless service, FAS, you can't keep that state. Also, FAS, there's no WebSockets gateway that no one's, well, there's the AWS MQTT IoT gateway, which is incredibly expensive, but most providers don't really have a useful WebSockets gateway. So it's a caveat you're going to have. If you want to implement GraphQL in FAS and function as a service platform, just realize you're not going to have access to subscriptions. For a lot of people, this is fine. For Bustle it was fine. Thomas Cook was fine. And you can also, there's other ways you can implement subscriptions. There's services like PubNub and Pusher and that. You can also do it for you. That'll be outside of GraphQL, though. Just a quick example of so Apollo, there's one of these framework providers. They've got a number of templates for implementing GraphQL within functions as a service providers. This is the Lambda one. They've got an Azure Functions one as well. I don't like this, and I'll explain to you why. But they make it really easy for you. So you define your type definition. So that schema definition language, that's just a string. Your resolvers, so hello responds to hello, and it'll respond with hello world. You declare an Apollo server, which bundles GraphQL and all the other enhancements they build around that. And you just give it type definitions and resolvers, and then you can invoke the handler function. And that works. Problem with that. What this is doing is the equivalent of this. It's building a schema off the schema definition language. So that type defs would be equivalent to that. and then it'll create a response. It invokes a GraphQL method, and resolvers will go to that root object. And then whatever your query is will go through as well. So what happens in every invocation on a FAS, if you use this, it'll pass your schema into AST. It'll then build your schema into a GraphQL schema object. It'll then pass your query. It'll then validate that query against the schema, and then it'll execute. But for a schema, that's essentially a constant in that doesn't change. It's doing this every single invocation. So that's the problem with that. There's a nice, that's really easy to write, really good to understand. It's not very efficient because it's doing this every time. And these are methods that GraphQL.js calls. It's not Apollo's fault. Can we add a build step to it, to our GraphQL schema object, and output that, have that predefined, pre-built, compiled GraphQL schema object and use that? No. Because JavaScript is JavaScript. You cannot serialize the schema object. So using JavaScript, so essentially it's a JSON object, but JSON objects can hold functions. You can't serialize functions in JavaScript. Because essentially when you compile that function, whatever the V8 compiler, when it interprets that function, the V8 interprets it. The way it compiles it could be different across multiple machines. It could be different if you use SpiderMonkey versus V8 versus WebKit, or whatever the actual JavaScript runtime is. And Node is always going to be V8. But it's a feature of JavaScript that you cannot serialize functions. So you can't essentially compile your function, which means you can't export your GraphQL schema object. So what are you going to do to improve this performance? Global variables. People say don't use global variables in FAS. You really, really want to use global variables. So the nice thing about JavaScript is you can just define a variable. You don't have to say what it is. You don't have to just say, hey, I'm going to reserve some space in memory. So you do that globally at the top, and then within your function, it's really simple, if statement. If the schema doesn't exist, so if there's nothing that hasn't been assigned any value, it will return undefined, which in JavaScript, so that's not whatever that is, will resolve to false. So if it's not false, it's true, then I'll go and build the schema. The next time you invoke it, this now has something in there, so it won't do that step again. So only on the cold start do you do that build step. So that's something you should add. Actually, it's a useful technique to use if you're writing functions as any functions where you want to optimize for, not your cold. Your cold start will always be your cold start, but if you want to optimize your performance, if you have any initialization steps, use that kind of pattern if you're using JavaScript. Other issues with potentially using Apollo Server, I'm picking on Apollo Server mainly because they're the most popular. And most people, it's the easy path. I'm going, don't use the easy path. Apollo Server plus GraphQL will be about 3 megabytes if you're using GraphQL 14. 2 reasons for that. Apollo Server asks you to install the GraphQL server as a separate dependency. It doesn't bring it in when you install Apollo Server. GraphQL on its own is about 3 megabytes. Apollo Server is a couple hundred K. The reason it's 3 megabytes is because it's got 2 versions of it. It's got the .js and the .mjs, so it's got the ES5 and the ES6 version, which is a problem. Ways to solve that, Michael Jackson script. This is an experimental feature in Node, but there are ways around it, because front-end devs have solved this problem already. Use a JavaScript bundler. So GraphQL plus Rollup, 360K. So it literally goes down to a tenth of the size if you're just using the raw GraphQL server and you chuck Apollo Server out. Also, a lot of the enhancements Apollo Server will give you, like caching, are useless in FAS, so it's a good reason to do it. This is just harder. Your developer experience is significantly more difficult this way, but your performance is significantly better. Or just don't use JavaScript. This is a company who moved from JavaScript to Golang, GraphQL. The other nice thing with Golang, if you want to implement Golang, okay, obviously not every provider supports Golang, but if you take GraphQL, Golang, it's a compiled language, not an interpreted language. You can pre-compile your schema, that executable schema. So you can do it as a build step outside of it. You don't have to do loading stuff into a variable. So if you are doing it at scale, I actually recommend use Golang over JavaScript. But to be honest, like Thomas Cook, Bustle, they use a JavaScript version, and they've got to millions of users. So it will still work. Yeah, that's the last thing for me is complexity is all in the server. The complexity is not on the front end. And this is a problem with most GraphQL tutorials. They are literally this. And my talk is a little bit like that as well, because I'd say I've only covered about 20% of what there is to know. I haven't touched directives or anything else like that. So yeah, that's me.